Hi, this is David, or Dave once again, and welcome to my YouTube channel. In this video, I will be once more testing a couple of industrial fans, the ones that you see in front of you. So my homemade Variac will again have the main star role in this video, and of course my digital multimeter VoltCraft VC404 will be there for voltage references, and I'll be securing everything into place with my screwdriver so the connections on this coupling will be sound and firm. Now, as usual, I'll give you a visual representation of each individual fan and tell you a little bit about the individual specifications of thereof. So I'll start with this one right here. Now this is the information that is printed on this label. You can here see the manufacturer name. So this one is an American fan in terms of origin. So it runs on 115 volts AC. It's in a actual industrial fan. The wires that you see here, I've just attached them for the purpose of this presentation or testing. So the case or the chassis is cast aluminum, I think. So it has approximately about 80 milliamps current draw. As you've seen here, it has about 9 plastic blades on this rotor. Of course, ball bearing. So how fast does this spin? Somewhere around 30 to 50 RPMs. The airflow is around a little lower than 40 CFM, 36. How much noise does this generate? About 40 decibels. And of course it has 8, so 4 here, up here, and 4 in the back, and 4 type mounting screws, should I say holes. So the diameter of this propeller here or fan is somewhere around 7 centimeters, 73 millimeters to be precise. It weighs about a little lower than 350 grams, and the dimensions thereof would be 80 times 80, and the thickness would be around 4 centimeters or 42 millimeters. Of course, here you have the grounding wire and the input AC voltage wires, which will be then later on hooking up and connecting and testing. So that's for this fan. The second fan that I'm going to look at and talk to you a little bit about is this larger one. So let's have a look. Now this is the label and the information on it. Unfortunately, this is a paper type sticker, and the problem or the disadvantage that the paper label has against, let's say, a plastic one is the paper eventually turns, as you can see here, a bit yellow, and if the text isn't well printed on this label, it also fades away. But nevertheless, and let's even disregard the scratches that have been made towards this label, we can still make a distinction that this is a 115 volts AC type of fan. So in terms of origin, It was built in Western Germany, but nevertheless it is made for the US market. Model number would be 4500N. The manufacturer is PAPST Motoren or EBM-PAPST. How much does this draw in terms of current or amperage? Around 130 milliamps. So the power consumption ergo is around 15 watts. It has 3 metallic blades, and the rotor spins roughly at around 3500 revolutions per minute. And the airflow that this fan is able to produce is around 170 cubic meters per hour, or a little lower than 100 CFM. And how loud this fan is? Well, a little lower than 50 decibels, 48 to be precise. How do we mount it? Well, we have the standard 2x4 first part here, then the second 4 configuration here. I think the holes are just big enough to fit inside a larger M4 screw. So how much does this weigh? A little lower than 530 grams. And the diameter of this propeller or fan as such is somewhere around 10 centimeters. Ergo, the overall dimensions of the fan would be almost 12 centimeters by 12 centimeters, and the height or the thickness a little lower again, and then 4 centimeters, 3.8 centimeters. Quite like that one over there, which I discussed previously. Now let's have a much closer look. Now here you have these 2 AC power wires that go into this compartment. This is sort of a securing piece of metal that prevents the wires getting out of this socket. And here you actually have the soldering contacts. So for the purpose of this presentation, I have soldered 2 wires onto here, and of course isolated them so I won't be creating any sort of short between them and blowing up the fuse on my variac. And of course here you would have where you would connect your grounding wire or cable. Yeah, this is this one here. And here I think you have the indication. Well, let's turn it around. Yeah, this is indication in which direction the blades spin, or the rotor, and where is the air pumped out or blown out. So this would be the sucking part, and this would be the blowing part. No sexual connotation, naturally. So the case has a few here and there bumps and bruises and discoloration, but still the fan kept its black color. Nevertheless, except this part, this one has also become a little bit discolored, so it's not black, but it's still functional fan, and we're going to see this a couple of moments when we will be testing it alongside the other 2. Now all there is left to do is to tell a little bit about the last one. The last guest on our review list is this fan right here. And this fan is actually brand new. It hasn't been used. It has been bought, I don't know, about 4 or 5 years ago. As usual, I'm terrible with dates. But it definitely hasn't been used, so it's in mint conditions. especially the body, again cast aluminum in black color. This is again, an industrial type fan, an actual fan. Basically, both of these fans have their body made out of cast aluminum, so I don't have to repeat it, the same fact on this one, but nevertheless. So this is the information that is printed on this plastic label. So how much does this fan consume in terms of power? So we have an interval between 19 and almost 20 watts. It has 7 plastic blades, and the rotor spins at around 2300 to 2750 revolutions per minute. It has a sleeve bearing. The airflow is rated at around 23 to 30 CFM. So the noise generated by this fan is also an interval between 31 and 35 decibels. And of course, you have the 2x4 mounting configuration. An M4 type screw would fit in here. And this one weighs around 330 grams. And the fan diameter, or the propeller diameter, is around 7 centimeters or 70 millimeters. The ergo overall dimensions are pretty much almost the same as this fan here, so 80 times 80, and the height or thickness is a little lower than 4 centimeters, 3.8 centimeters to be precise. Now let's have a much more closer look. So you see, you also have this metallic piece here to hold the wires in this trench. The insulation is a bit longer. And this is where you would connect the ground wire, which I forgot to do. So I'll be probably borrowing or unscrewing the ground connector from this fan and probably attaching it over here. Hopefully the screw is the same one, or else I'm going to have to add another one. And of course here you have again the indication on how the rotor spins and the airflow direction. So this would be where the air goes in, and this is the place where it is blown out. So the chassis or the case is, in mint condition because it hasn't been used and it has been stored properly. So no bumps, bruises, discolorations, any defects or chips of this chassis. Everything is in perfect condition, and we'll also see the functionality of this fan as well when I test it in a few moments. We're in the middle of this video presentation, so the first part of this video was centered on giving a visual inspection on each individual fan, and then talking about its specifications for each fan specifically, individually. And now I'm going to go actually to the testing part of this video, and the first fan that will be under stress will be this green labeled one, Sun fan, because this one is rated to work at the voltage of my AC wall socket power, so 220 to 240 volts. Why I'm doing this fan first is because the other two work on the US AC wall socket voltage, so it will be much more convenient for me to first get away with the first one and then just center on the other two, only using the 115 AC voltage, so I won't mix anything up. So the variac is powered on, the fan is connected, the multimeter is also ready for fiddling. So the variac has been connected via this primary input power cable to this AC power cord, which is then of course connected to my wall socket. And then this secondary white cable, this is where the AC voltage will be generated via turning this improvised knob clockwise. It's also ready. I have inserted the multimeter test probe leads into the correct allotted slots. So in these two slots are also the input AC voltage wires inserted. And this ground wire, the green one, I actually had to unscrew it via the M4 screw from the larger fan, so I could borrow this green wire in order to make everything safe, grounded. So now all that there's there left to do is of course start turning the knob with the usual 50 volt AC initial increment to see whether the fan starts to spin at this point, and the visual presentation or indication will be the small hole right here. This is where you'll be able to see whether the blades or the rotor starts to spin. Of course, the multimeter has been set in the correct AC voltage measuring range, 750 volts. So now I'll just probably zoom in on this part here so you can have a closer look. And then I'm going to zoom in on this part and we'll start experimenting. Now this is how it looks like up close, nothing special. Of course, you have the ground wire going into this yellow greenish wire, which is the ground, and then these two wires don't really matter how they go, and of course the multimeter test probe leads, because this is AC, so polarity here isn't the question. So this is for this part. I have moved the camera into a much more better viewing angle position. So now let's start turning the knob. So we're at 50 volts AC and nothing is happening. Let's see if we give the fan a little gentle push. Maybe. So at 50 volts AC, the fan already starts to rotate. So of course, this will be indication where the airflow will be blowing. So towards me, I'll be again feeling the cooling effects. So perfectly, the fan with a little aid of applying kinetic energy, this is where it starts to spin. Now let's go again, 50 volts up again. It's really quiet. I can barely hear it, but I can feel the airflow. So this is definitely a much nicer fan in terms of audibility that I have encountered. So let's go into the US AC voltage area. Alright, now I can hear it a little bit more, being audible. Maybe you can as well. Alright, let's go up 50 volts again. Now you can really start to hear it. So now the fan is a bit more louder, but you know, still nothing in comparison to the first video I did on the testing of those two industrial fans that I had. You know, the silverish color. Whew. Now the airflow is really wonderful. But it's still, you know, a nice quiet fan. So let's go to 220 volts, which is the lowest AC rated voltage of this fan. There was just a bare increase in audibility, nothing severe, so it's still regularly a much more quieter fan. I can feel a little bit of the vibrations if I touch on it, but it is really cooling nicely. Alright, 240 volts. So this is the maximum according to the sticker, or what is written over there. Yeah, it's actually over here. So 240 volts. Still, overall speaking, this is a really nice fan. Quiet, but giving the necessary airflow or cooling effect as such. I'm actually really surprised. Maybe I shouldn't sell this one. Let's zoom out a little bit. So yeah, well, this is it. So now I'm testing one of the other two 110 or 115 volt AC fans. So in this one, in this part of the video, I have the larger one here that will be stressed or tested. So everything is connected just as it was with the first one. So the multimeter is set in the correct measuring range. The test probe leads are connected into this coupling, and also the input AC voltage wires as well, and the grounding wire. So all there is to is, of course, start turning the knob, but this time I will start with less than 50 volts AC in terms of initial increment, because this one will start spinning probably much sooner than 50 volts. So I'll probably just zoom in again on this part so you'll be able to see it much more clearly, and then we'll continue. So this is how it looks like, again connected. Here you have another angle. For visual references, you have a lot more space this time to look at in order to give you a nice indication window when the three-bladed rotor might start to spin at which voltage. So I'll start with something low, like 30 or somewhere around 30 volts, to see whether the fan or the rotor starts to spin. So let's see, 31, 32 volts, nothing is happening. Let's see what happens if we give the fan a little push. Will be this enough rotational kinetic energy applied in order to start it to spin? Well, apparently so. So this is the lowest hand assisted voltage when the fan starts to spin. So we'll go to 50 volts. So you can hear the fan starting to speed up and also noise starting to appear and or increase. But of course this is because these wires that are on the ground, they have lifted the fan a little bit from the ground, so it's not exactly quite even surface, so that is also amplifying the vibrations. So if I take it in my hand, for instance, or lift it off the floor, it's actually very quiet. You can barely hear it. So let's go to 75 volts. Now the cooling is really starting to make its way. I'm not getting chilled because this is the intake or air intake in the direction, and this is where it is blowing out or cooling. Of course now the fan has become much more louder. Again, let's see what happens if we move it off the ground. Yeah, it is louder. Alright, 100 volts. Cooling is wonderful. So it's still loud, but nevertheless effective and functional. So now let's go to the maximum, 115 volts. So this is the maximum, the nominal, you could say, rated voltage. Maybe a little rattling sound on the rotor, a little bit. You gotta watch my fingers. So it's cooling very nicely. The airflow is great. So I'm done for this fan. So now I have to test the last one, which is also ready to work at the 115 volt AC range, 110. So we'll disconnect everything and bring in the new one into this place. Now in the last couple of minutes of this video presentation, I have the last fan ready for testing. Everything is connected, wired as it should be. So this is the last industrial fan that I will be stressing, fiddling around with. I'll just zoom in a little bit on this part so you can see how everything is hooked up once again. Then we'll start turning this plastic gear or knob. The money shot, if I want to call it as such. And this angle, how it looks like. For your visual indication on when the rotor and with its allotted blades will start to spin, pay attention to this small opening right here. So I'll start with, again, 30 volts AC. And we'll see how it goes. So basically nothing at 30 volts AC. Let's see if we give it a little assistance. So we do have some movement, very slow RPM at 30-31 volts AC. So let's go to the usual place, 50 volts. So at 50 volts the fan is rotating nicely. You can also barely hear it even though I have it on the ground. So it's nice and quiet. Let's see how it is with the cooling. Nothing. Maybe a slight breeze. Let's go to 75. Now the audibility of the fan is increasing, or has increased. The cooling is a little better, but not anything like in comparison with the previous fan. So it's still a very quiet fan. Alright, 100 volts. Now the audibility is rising. Sounding like a jet or something. Ooh, now the cooling is brilliant. Oh, this is what I'm talking about. So again, this is the air intake, and this is the part where, or direction, where the air is blown out. Alright, here we see it's written 115 volts. So let's go to the maximum. So this is the maximum voltage. And the fan is, well, it's a little bit louder, but the cooling is just brilliant. Let's see if we lift it off the floor a little bit. So it's working perfectly, it's functional. Another thing that I also noticed with this fan is that if I turn the voltage completely down, it stops in a matter of seconds. So this is interesting. So you see, the blades are not spinning anymore, or the rotor. So a couple of seconds. So this is really great. This is then, ergo, the end part of this entire video presentation on testing another set of 3 industrial fans, this time in a much more blackish color and not silverish as the first 2 that I did. Hope you enjoyed the presentation, my narration or comments during entire this time of the video. And as it goes, comment, like, subscribe, and share. And we'll see you in another video where I'll be probably testing a pump motor from a dishwasher or a washing machine. But until then, this is David telling you goodbye and have a nice day.